Good afternoon. My name is Fedelucio Narducci, and I'm presenting ExpLOD, a framework for explaining recommendation based on the linked Open Data Cloud. The problem addressed in this work is that when a recommender system is implemented as a black box, it doesn't explain the motivation behind a recommendation, and it doesn't show the internal mechanism its internal mechanism to the user. Generally, a recommender system acquires the user preferences, elaborates it, computes it in some way, and recommends an item. However, the user could be interested in knowing why she received that recommendation and how that recommendation is correlated to her preferences. A possible solution to this problem is that explanation. I recommend you Cloud Atlas because you often like films with Tom Hanks. And in addition, you sometimes like films directed by the Wachowskis. How can we obtain this result? The main intuition behind ExpLOD is to connect the recommended items and the user preferences by properties extracted from DBpedia. So the first step is to perform an entity linking process that assigns to each item the DBpedia URI, so we are able to extract the DBpedia properties for that item. This is the general architecture of ExpLOD. It is composed of 4 main components. And the strength of ExpLOD is that it potentially be used with any recommendation algorithm. The first step is performed by the mapper that associates to each item the corresponding DBpedia URI. Next, given the properties extracted for each item from DBpedia, the builder builds a graph-based data model that connects the recommended items and the user preferences, so the liked items. Next, the ranker selects the properties that to be exploited for the explanation by computing a score that is a linear combination of ingoing and outgoing edges of each property, weighted by the IDF of that property. Finally, the generator generates the natural language explanation. This is an example of explanation generated by ExpLOD. The explanation starts by the sentence, I recommend you this item because, in this case, you often like films with Tom Hanks, since Tom Hanks is connected with 2 liked movies. In addition, you sometimes like films directed by the Wachowskis, since the Wachowskis is connected with another liked movie. The adverb often and sometimes are chosen according to the score computed by the ranker. There are also other properties that in this case are not exploited, that have been not exploited for the explanation given their scores. We carried out a preliminary evaluation by a user study. We involved about 300 subjects with medium interest in movies. And we mapped about 90,000 movies from IMDb. We compared 4 different explanation approaches. The simplest baseline is a sentence: I recommend you this item because it's very popular. And another simple explanation that is based on the description extracted from the LOD properties, and 2 approaches based on ExpLOD. We adopted 5 metrics, and for each metrics, the user expressed a rating on a sentence. For example, for transparency, I understood why I received the recommendation. We formulated 2 research questions. The first one investigates whether ExpLOD is able to generate more transparent, persuasive, trustful, or engaging recommendation. And the second research question investigates the correlation between the properties extracted from Wikipedia and effectiveness of the explanation. This is the user journey. The user asked to provide basic demo data, to provide preferences, to read the explanation and express a rating for each sentence, and finally to express a rating before and after watching the movie trailer. The answer to the first research question is yes. Indeed, we can observe that the best average rating in bold for the first 4 aims is obtained by the ExpLOD-based approach. While for the effectiveness, we computed the average error between the rating before and after the trailer consumption, and in this case, the best result is obtained by a simple description based on the LOD properties. And also the answer to the second research question is yes. In this case, we can also observe that there are some properties that positively affect most of the aims, and there are other, such as director or writer, and there are other properties that negatively affect the aim, such as distributor or producer. This is an interesting result for generating aim goal-oriented explanation. That's all.
Thank you very much. A really interesting paper. I like it very much. I have a question which might be a challenge. You remember many years ago during Netflix Prize presentation at RecSys, there was a very famous citation that all metadata, that was about the movie recommendation, all metadata are not worth as much as one single rating. On the other hand, it looks like you're successful using exactly the metadata. I mean, authors, the directors. The question is, if the recommendations are produced really not using metadata, but using some mystical collaborative filtering approach, which is a kind of black box, is there any hope that we can explain in using glass box? Of course, if it's produced using glass box, it's natural that we can explain it in a glass box way. But the question is, can we explain black box using glass box, although the real mechanism behind is not transparent?
Yes, it is a very good question, since in our future work, we wanted to investigate different recommendation algorithms. Since in this case, we exploited a recommendation algorithm that is based on the same graph data model that is used for explaining the recommendation. But so it is required that between the recommended items and liked items, there are connection by means of the DBpedia properties. This is a requirement of the system.
I have a question for you. When you administrated the questionnaires,
yes,
did you control for age and for previous experience with recommender systems?
Yes, we asked the user to express their ability in using a recommender system, and we obtained an average and medium experience with these systems.
What about age?
The age is under 40.
And did you test for users above 50 or 55?
No.
So my question is similar to maybe the first question that was asked, but I wanted to maybe just dig a little deeper. So is this approach for explaining only, or is it
Yes.
both for explaining and recommending, right?
The framework is only for explaining.
So the follow-up question is, so if it is for explaining only, right, then it may not be explaining accurately, right? If the actual recommendation was generated from some other, let's say, here's a matrix factorization approach that did this really, really good recommendation. Now we're trying to explain it and we found these connections. But this is not why you recommended it. You recommended it because there were some latent factors that were, so what do you think, like, it's nice that user sort of receives some explanation and sort of makes the user maybe accept the system better. But it's really not exactly why the item was recommended. It's just something that was, easily explainable to the user, but it's not accurate per se. What's your opinion about that? I mean, there's a trade-off.
Actually, this is a point that we need to investigate because, as stated before, now we used a recommendation algorithm that is very similar to the explanation model. So it could happen that in the case we exploit another recommendation algorithm, the framework doesn't work very well.